Okay, so basically we have already isolated out the omega and the omega of rod AB, BD and DE. So for the next part of the question, it asks us about the angular acceleration of the bar BD and bar BE. So how do we intend to solve that? Just as I said before, only two equations needed, the velocity equation and the acceleration equation. As for the acceleration equation, right, in this case, since we are interested in finding the angular acceleration, so intuitively you should kind of know that we are going for the acceleration equation. So let's just put out our acceleration equation first, right? So first of all, they want us to find angular acceleration for bar BD and bar DE. So how do we intend to do that? So first of all, lay out the angular acceleration formula, the acceleration formula for relative translating reference frame. So in this case, let's say we want to find the acceleration of D, just like before. So acceleration of D is equals to the acceleration of D with respect to B plus the acceleration of B. So this is what we know and we gather. In this case, right, so just like what you did before, just plug everything in accordingly. No magic, everything is just fine. So first of all, let's solve for AD. So how do you find AD first? In the first place, just like what we did before, we have no idea on what is the magnitude of AD. But we know one thing, for sure in our absolute, as an absolute motion viewer, we know that D is registering a circular motion around E. That is D's absolute motion. Okay, so how do we talk about the acceleration of D? The acceleration of D in this case can be divided into two components, the centripetal acceleration and the tangential acceleration, right? So we can say that since D is registering a circular motion, D has actually two parts of acceleration, the centripetal acceleration and the tangential acceleration. So first of all, let's just write it down sequence by sequence. So basically acceleration of D is equals to acceleration, centripetal acceleration of D plus tangential acceleration of D, right? Or if in the class notation, it is more convenient to write in the sense that this is A is the radial acceleration, means it's pointing in towards the center of rotation. Okay, and it's equals to take a look at this acceleration of D with respect to B. What is acceleration of D with respect to B? In B perspective, D is also registering a circular motion. So this acceleration of D with respect to B also have two components of acceleration. The first component is this. This is actually for E perspective. So in B's perspective, D has also two kinds of acceleration: centripetal acceleration and tangential acceleration. Right? Because D is registering a circular motion around B. So that is the cool thing to do. So you can see that acceleration of D with respect to B also has a radial acceleration plus a tangential acceleration. How about acceleration of B? We know that B is going in a constant angular velocity around A, right? Because it gives you the A has a constant, omega AB has a constant angular velocity of 3 radians per second. Constant angular velocity means that the angular acceleration is 0. So in this case, we know the acceleration of B is only the centripetal or the radial acceleration of B. With respect to what? With respect to us or with respect to A. Because A and us are not moving, so A shares the same velocity reference frame as us. Meaning to say, B is rotating around A in our perspective, and we as the absolute motion viewer, because we have no velocity and such, will think that B rotates a constant angular velocity around A. So there is no angular acceleration of B around A, there's only angular velocity of B about A. Okay, good enough. So we have laid out all this thing, and take note B has only radial centripetal acceleration, there's no tangential acceleration all once. Okay, so ARAT. So let's just plug in this formula one by one. So how about AD? So what is the radial acceleration or centripetal acceleration? So just to make sure, this R, I think let's just use this convention. So C as a centripetal acceleration. Okay. So what is the centripetal acceleration of D? Because in our perspective, D is rotating a circular motion. Not in B's perspective, but in our perspective, D is rotating a circular motion around E. In B's perspective, D is registering a circular motion around itself. But in our perspective, we think that D is registering a circular motion around E. Right? Okay, so how do we actually decode the first part? Centripetal acceleration of D about E, or centripetal acceleration of D, I mean, it's rotating like this in our reference frame. So the centripetal acceleration of D, because it's centripetal, so it will always go towards the direction of the center. In this position, the centripetal acceleration is defined as omega square r, which in this case is RdE, meaning the length of this length, dE here, times omega dE square, which omega dE can be found from the previous example. Okay, and the direction for this centripetal acceleration is in this direction, right? So it is actually 0 degrees. But remember, this is not all. This is only the centripetal acceleration of D. For the tangential acceleration of D, tangential acceleration of D is actually can be in two directions. It can go up here, or it can go down here, right? Tangential acceleration of D can be either in this or this direction. Now D is rotating about E, so tangential acceleration of D can be in this direction or this direction. So then again, which direction should we choose, since we have no idea on the angular acceleration of D about E? So in this case, we will just, put the magnitude of D as of D tangential as an unknown. So let's just say we don't know what is tangential acceleration of D, but we do know that tangential acceleration of D is equals to the radius of D times the angular acceleration, right? So it's angular acceleration D, right? And the direction can be either going here or going here. So according to our convention, we always take the direction as counterclockwise. So in this case, down is the thing to go, so we just go negative 90. Okay? Let me re-explain. So what we are trying to find out is the tangential acceleration of D about E. Alright? So the tangential acceleration of D about E is actually can be in two directions, up or down. We don't know which direction it is, so we just assume that it is a counterclockwise position, counterclockwise direction. Why? Due to convention sign purposes. So we just take it as this direction, so it's negative 90. And we also know the tangential acceleration of D, because D is registering the circular motion about E, is equals to alpha r, where alpha is the angular acceleration of rod dE, and r being the distance of the radius of D to E. Understand? Good. So this whole thing actually describes ADC plus ADT, which is equals to AD. This whole thing is the equation. This whole thing here will be plugged into this part. Okay? Good enough. So in this case, we already finalized our ADs, right? So we will use the same method to decode for AD based on B and AB. Okay? So how are we going to proceed from this idea? Very well. How are we going to proceed from this idea? Well, actually, if we have this formula here, we can just sub it into AD here. So let's just do the subbing right now. Okay, so because I got no space left. In this case, alright, let's just write this away. Okay, let's leave this here. Let's just copy the whole thing from here upwards. So now I got RdE times omega dE square this whole thing is equals to my AD. Right? Okay? This whole thing is equals to my AD, and this part here is actually my centripetal acceleration. This part is my tangential acceleration. I got the value of, so this is AD. So now I want to find AD based on B, because the initial equation we actually set up before. There's the cost of this guy. So let's just write this here. Just ignore this whole thing. The initial equation that we are always concerned about is this. Acceleration of d is equals to acceleration of d with respect to b plus acceleration of b. Right? So this is acceleration of d. You accelerate it out. So now we want to find acceleration of d with respect to b. Okay, so for the acceleration of d with respect to b, as I said before, b thinks that d is rotating a circular motion around itself. Right? That's acceleration of d with respect to b. So in this case, this acceleration here also have two components: centripetal acceleration about b and tangential acceleration about b. So this is centripetal acceleration. So let's talk about the centripetal acceleration first, okay? In b perspective, d is rotating around it. So in b perspective, d has a centripetal acceleration. Where is the centripetal acceleration directed to? Upwards, because towards the center of rotation, which is b. In this case, right? So this is how it goes. So what is the magnitude for the centripetal acceleration? The answer is still the same, omega square r. So the r is the distance between the RBD, and the angular velocity is the angular velocity of the rod BD, and the direction, this is actually square by the way, this is actually the centripetal acceleration, okay, of D with respect to B. Good enough? Now this is that, and the direction, because you know the centripetal acceleration, it always points towards the center, so the answer is actually 90 degrees. Okay, so this is centripetal acceleration of D with respect to B. Now, there's two components, right? This is centripetal acceleration component. So the second component is actually, what component is that? The second component is actually the tangential acceleration component. So we are trying to find another component which is denotes the tangential acceleration of D with respect to B. And this tangential acceleration can only go in two directions. It's either, because it's a circular motion, or we know confirm this is circular motion, so tangential acceleration of D with respect to B can only be in this direction or this direction. So which direction we choose? Then again, because we always stick to the convention, because we don't know where it turns, we don't have any information on the angular velocity itself, in the angular acceleration itself. So D, in terms of angular acceleration, tangential acceleration, sorry, can go in this direction or this direction. And in this case, as I said before, we always choose the direction at which D is seen to be rotating counterclockwise. So let's say it's accelerating this way. Okay? So we can claim that the direction of D is in this magnitude here. Okay, because we assume that D is rotating counterclockwise. So D is like, in terms of the tangential acceleration perspective, D is like accelerating in a counterclockwise manner also. So in this case, what is the tangential acceleration of D? It's actually RBD times the angular acceleration, which we don't know, so just put alpha BD, and the direction, due to sign convention, we just said before, counterclockwise, so D will be in this direction, right? Because it's turning a circular motion like this. So at this point, it's going here to the right, so it's actually 0 degrees. Very good. And now we have created the formula for the acceleration of D with respect to B. So basically, this is the centripetal part, the acceleration that's pointing this way. And this is the tangential acceleration part, the acceleration that points this way. So when omega square R, one is alpha R. RBD, RBD, alpha BD, and omega BD. Okay? Omega BD, you found this from previous calculation. So let's just isolate this out again. So basically, I have two equations now. So I just copy this thing up here now. So I want to just make it very clear. Now I have two equations. This is the first equation. It's a bad presentation. Can I see this? Okay, I can see it. So this is 8. So, I can't stand it. I have to arrange this. So this is what we just isolated before. Acceleration of D, you can skip this part if you just want to fast forward. So D with respect to B. Okay, here's it. So we have found two equations. This is the first equation that describes acceleration of D. Second equation that describes acceleration of D with respect to B. Okay, cool. Now there's only one more part to left, acceleration of B. So how do we find acceleration of B? Acceleration of B is actually much more simple in this case, because acceleration of B is always has no angular acceleration. So basically, it only has a centripetal component. So the centripetal component, because acceleration of B is rotating about A, right? So acceleration of B is in this direction, centripetal acceleration. So what is the direction here? The direction here is actually, this is the direction of centripetal acceleration of B. Right, this is the direction for centripetal acceleration of B, because B has no angular velocity, has no angular acceleration, so it only has centripetal acceleration, so it's only pointing in this manner. And this theta here is actually equals to 18.435. Then you can use Trigo to calculate out yourself. So basically, acceleration of B is equals to the centripetal acceleration, which is RBA times omega BA squared, and the direction is equals to 18.435 degrees. The direction. Okay. Now, pay very close attention to this. AD. Which are the quantities that you have? You have RD. Do you have omega D? You have omega D, because from the previous question calculation. You have RD. You have no omega D. This one you want to find. Cool. Second part, you have RD, you have omega BD from the previous question, and RBD you have, but omega BD, well, you don't really have. For the last part, you have RBA, because it's on the diagram here. RBA, RBD, RDE, all is on the diagram here. How about omega BA? Do you have omega BA? Yes, you have, from the question itself. So basically, out of all these three things we have here, there are two unknowns. First unknown and second unknown. And these three equations, AD based on B, AB, is all related in this equation. So what you have to do is just copy and paste, and then you will have a very long equation in terms of AD based on B and AB. After that, since it's so long and so complicated, what should you do? Same thing. Dot product. Look at this. This is something that will be very messy if you will try to solve it using the matrix method, because you have all this unwanted stuff here. If you were to use dot product, believe me, you will cancel out a lot of things. For example, if you were to dot product with 90 degrees, because you got 0 degrees here, right? So I'll cancel out this, for example. You dot product with 90 degrees, this term and this term automatically deleted. And this term becomes cos 0, so you just have this. It's a very simple process. So try to work it out using dot product and you will get your answer. So this concludes these questions. And finally, when you found your answer, for example, alpha DE, for example, let's say that it is, -6. What does this -6 radian per second means? It means that this is actually, the angular acceleration direction is actually in the clockwise direction. If so-called angular acceleration is positive, means that the angular acceleration is in the counterclockwise direction. Okay, so sign convention is important. That's why